In the last session, we just noticed what happens when the BGP sessions are flapping at regular intervals. But it may so happen that your BGP sessions are flapping randomly. And one of the problems that could be causing those flaps is high CPU. If the CPU utilization is high on the router, you might experience packet loss. CPU is busy processing some other packets, some other messages, and it is not able to give control to BGP or other control plane protocols, and that's when the processing doesn't happen for the messages received from the neighbor. So say for the router is sending the keep alive, but the CPU is high on the router, busy processing some other packets, say for packets with TTL set to 1, packets destined towards the loopback interface of the router, or packet destined toward the router, any of the interfaces. All those packets are actually sent towards the CPU to get processed. If there's huge traffic coming on to the router CPU, the CPU can definitely get busy processing them. That's where the impact happens. You might want to apply different features to prevent the CPU from getting hit by different kind of packets. If the packets are coming with TTL size of 1, if the packets are coming destined towards the router which they are not supposed to, you might want to block those packets. You might want to set rate limiters for such kind of packets. You can do different things with it, but definitely high CPU can actually impact BGP sessions and can cause random flapping of the peering. With high CPU, it is important to gather historical data. With historical data, you can identify how frequently your CPU utilization is being hit, how frequently there are packets that are continuously hitting the CPU. The historical CPU utilization data might not tell you if the CPU is high because of packets hitting the CPU or it's high because of a certain process. How do you verify that? You can actually verify that from the command line. Let's go look at it. When you run the command show process CPU sorted, there are two important things that you need to look at. The first field highlighted here shows that the present CPU utilization. The second field shows you the CPU utilization because of interrupts. Interrupts means traffic. So say for if your CPU utilization is high up to 100%, and out of that 100%, if 90% of the CPU utilization is being taken due to interrupts, that means there are packets that are destined towards the CPU, and you need to rate limit or block those packets from hitting the CPU. And this can happen not just because of packets destined towards the CPU, it might also happen when your packets are not getting hardware switched. They are getting software processed. If the CPU is not high due to interrupts, then you might want to see if a particular process is causing the high CPU utilization. The show process CPU sorted command actually tells you the history of last 5 seconds, 1 minute, and 5 minute data, and says if a particular process was high or using most of the CPU resources, how long it has been reusing that resources. And based on that process, you can actually troubleshoot why that process is consuming most of the CPU cycles. There's SNMP engine. There's a particular MIB being polled, which is causing the CPU utilization to spike up for the SNMP engine process. Similar with other processes related to IPRIB event, if the routing table is getting updated, or any other process related to OSPF. Any of those processes can cause CPU to spike up, and you can troubleshoot based on the process. Most important fact with that is you need to understand what those processes do, what functions are performed by those processes. You can finally look at the historical data of last 72 hours on the router itself using the command show process CPU history. It shows you the historical data of last 60 seconds, last 60 minutes, that is 1 hour, and last 72 hours. So if you notice, around 6 hours ago, the CPU utilization was high on the router. So you might want to go back and see if it was just a one-time event, we could have just ignored it. But if it was something that is continuously happening, then we might want to capture that data. If the CPU utilization was high around a particular time interval, and if the BGP session also flapped around the same time interval, that would correlate and help us identify why the BGP session actually flapped.